But today we're solving rational equations. So really, I've kind of showed you how to do that in the last few days. What do you think you want to do when you see something like this, a fraction over a fraction that are equal to each other? You do. You really do want to cross multiply. So when you do this, it's always top times bottom. And then it's equal to bottom times top. So you'd have 5 times 3x minus 5. Now, just like on the bell work, this time it's better to multiply those through, right? Because then you get solid x's, solid numbers that you can solve. Because we're going to get an answer for x this time. So when you multiply this through, you have 20x minus 40. Someone shout out what I get on the other side.
15x minus 25.
Yep, 15x minus 25. Now my goal is to get all of the x's together on one side. So which way do you want to move your x's? You want to move the 15 or do you want to move the 20? Yeah, I always like to move it to keep my x's positive, so I'm going to minus the 15x over. In the same step, can we move the 40 or do you want to wait for the next step?
Add the 40.
Add the 40 at the same time. Because really we want to isolate those x's, right? So we know those 40s have to go to the other side. So they cancel here and those cancel here. So what am I left with?
5x
Equals,
15.
so x equals 3. So really what that means is the number that satisfies so that this fraction is equal to that fraction is the number 3. Now we would always want to put back in and check, because does anybody remember what can happen on fractions? You can have a special kind of solution that doesn't actually work. Anybody remember what those are called? Oh, they're called extraneous. Do you guys remember that word from before? We sometimes find extraneous solutions, solutions that appear to be an answer, but when you substitute them back in, they don't work. So really fast up here, we'd have 20 divided by 3 times 3, which is 9, and 9 minus 5 would be 4. So 20 divided by 4 would be 5. And we're going to see if it's the same on this side. So we'd have 5, then we'd have 3 minus 2, which is 1. So 5 divided by 1 equals 5. So that checked out, right? So always just quickly plug it through, make sure it checks out so that you know that that's a solution. Okay? Next one, cross multiplying. So are you guys okay this time, instead of writing it out like this with the parentheses, if I just cross multiply and take that 6 through to both parts? Is that okay if we do that in one step? All right, so negative 6 times x would be a negative 6x, and negative 6 times a negative 1 would be a positive 6. Everybody agreeing with me on that? All right, tell me what you get the opposite direction then. Good. Then what? Right here, what do I get? I already did it.
Oh, 24.
Minus 24, thanks. Okay, I need to get my x's on one side together. So again, I like to move mine so that my x's are positive, but you can do it either direction. So what do you want to do? Add 12x, okay? When I do that, are you okay if in the same step I get rid of the 6 that's on this side to the other side? So I'm going to minus the 6 over in the same step so I don't have to do more than one set of work there. Over here I get a positive 6x. Over here I get a negative 30. We good? What do we do from there?
Divide both sides by 6.
Yep, divide both sides by 6. And x equals... And again, we're going to sub that in real fast to make sure that it works. I know it's kind of a pain in the butt, but you'd have negative 6 over negative 5 plus 2. And I want to know if that's equal to negative 12 over negative 5 minus 1.
Yep.
So here you'd have positive 2, right?
Yep.
And here you'd have positive 2. Did it check? It did. Okay, so again, checking for extraneous solutions. And here it actually talks about those. So it says possible outcomes to watch for. Sometimes answers are fractions or irrational numbers. Not everything works out to be a nice integer like 5. Okay, you might have 1/2, you might have 0.3. They're not always going to be nice, okay? Sometimes there's no solution, which is what we're going to do in example 3 in just a minute, so be ready for that. Sometimes there is more than one solution, and sometimes there's one or more apparent solutions that are really extraneous solutions, and we're going to do that in example 6, okay? So again, different ways we can have our answers. So here's example 2. This one's going to be a fraction answer. Isn't it nice that we tell you to not be freaked out? That doesn't happen on the worksheet, you guys. You have to just figure it out yourself. So cross multiplying. Tell me what you get this direction.
9x plus 24.
Perfect. 9x plus 24. And the opposite direction? Okay. Moving my x's to all be on one side together. I like to keep them positive, but it's up to you which way you move. But I want to move the 5 over to here. I'm going to subtract the 5x over. And what am I going to do with this 24? Yep, minus it over. And again, you could do that in 2 different steps. I just like to do it in one because I know that I have to do it anyways. So it just makes it easier to do it in one step.
You can't minus the 10 over?
You could, but then the x's and the numbers would be on the same side together, and you'd have to remove that number back over to the other side. Yeah, but you totally could. You're just doing more work than you need to. So 9x minus 5x is 4x. And 10 minus 24. Oh, I'm just kidding. I wanted that to be nice, didn't I? My brain thought something different than my hand wrote. Negative 14. Divide by 4. And you get, just reduce that for me. Yeah, 7 over 2. If you wanted to write that as a negative 3.5, you totally could. Right? And you might want to just because it might be easier to substitute back in as a negative 3.5. That's up to you. So when you sub it in, you'd have 3 over negative 7/2 plus 2. And you want to know if that's equal to 5 over 3 times negative 7/2 plus 8. So kind of a mess to substitute back in. But this would be 3. And remember, if you think about this as a negative 3.5, it might be easier. Negative 3.5 plus 2 would be a negative 1.5. 3 divided by a negative 1.5 would be negative 2, right? And then over here, you'd have 3 times a negative 3.5. And then add 8 to it. Did they equal the same thing?
Mrs. Clark's room. Sure. Okay.
So on the bottom, you'd have a negative 2.5. So you'd have 5 divided by negative 2.5, which is actually a negative 2. So that does check back out in order to be the right solution. So you guys, again, just plug it back in, let your calculator do the work. You could totally substitute it back in exactly the way that it looks like right here on your calculator if you take the time to just punch it in. Okay? All right, this next one, little hint up at the top, what are we going to get right here? Okay, so what do you think is going to happen if we're going to get no solution? Does anybody remember? It's not going to work, I heard. And I heard somebody say you're going to get that empty set solution, that circle with the line through it is going to be the way your answer looks. But does anybody remember what happens to the variables when you get no solution for your answer? What did you say, Jesse? Oh, okay. That would be an extraneous solution. And that would also be no solution if we only had one. Okay, let's look and see. I mean, I know what's going to happen, but hopefully you guys will remember. What happens right here when I cross multiply? 3x minus 3. And the opposite direction? Oh my gosh, guess what I get to do? Yeah, I love to FOIL. We get to FOIL this. I know. X times x is x squared. X times 2 Yep. Negative 1 times x. And negative 1 times 2. All right, we have a squared term. So does anybody remember what we have to do when we get a squared term?
Quit.
Quit? Oh, you guys are cute.
Square root it. Right?
We got to have it set equal to 0, right? It has to be set equal to 0. But let's simplify over here. Over here we'd have 2x. I'm just kidding. X squared. That would be plus 1x minus 2, right? And on the other side, we still have the 3x minus 3.
Add 3 to that.
Add 3 to the other side. Also, I'm going to subtract that 3x over, right? I don't see how this one's no solution. Like, I see solution. Do you see a solution?
X minus 1 squared.
Yeah, we'd have x minus 1 when we factor that, right? So, and I wrote it separately just so you could see it happening. So we're thinking x equals positive 1, right? So you guys are right about this one probably being an extraneous solution. So sometimes, and let me tell you what I was thinking about. You guys sub it in real fast while I'm talking to you, okay? To see if it works or doesn't work. And actually you can see it's not going to work from the bottom of the fraction. But I want to bring up a point right here because normally when we've solved in the past and we got no solution, it was because we ended up with no x's left over, right? We'd get like 0 equals 4. And that still can happen. If your x's cancel out and you're left with a false statement, then it's still no solution. So that still can happen. But right here, you have a big problem because all chapter long, what have we worried about? The bottom of the fractions, right? And what happened with that solution that you just substituted in there? It gave me a 0 on the bottom of my fraction. Can I have a 0 on the bottom of my fraction? Nope. So guess what this one is? It's no solution. Okay? Because our solution that we found made it impossible to do the math. Okay?
Do math too, Nick.
All right, so it talks about extraneous solutions. It has you remember back to the square root equation. Sometimes you get an answer that when you substitute it back in, it doesn't actually work because you can't take the square root of a negative number. So, and the same thing happens here. Rational equations have their own domain issues because you can't have numbers on the bottom of the fractions that make the bottom of the fraction 0. Okay, so just a reminder that that happens. So it's important to check your solutions to make sure that they actually work so that you're not dividing by 0. Okay, all right, a few more examples, and this is where it changes just a little bit. You guys are cracking me up. Okay, this has some addition into it. So what we're going to have to do this time, what do we have to do when we're adding stuff together? We have to find the common denominator. We're totally just going to do what we did a while ago. So what's the common denominator for x, 3, and x? 3x. Because you remember how I said take one of everything, right? So I'm just going to rewrite everything over my common denominator, which is 3x. Okay. What was the x right here missing to get to my common denominator? So what am I going to multiply the top by? 3. What is this one missing to get to my common denominator? It's missing x. And what is this one missing? 3. So I'm going to multiply the tops by the numbers that I need to multiply by. 3 times 8 is 11 times x is, yeah, and negative 14 times 3. We good with that? Okay, once you have everything over the common denominator, I could totally explain to you all of the math of why this will happen, but we really just get to forget about the bottom and solve the top. Okay? I don't think that you want me to take the time to explain the math behind it. Just believe me that it works and do it, okay? So we no longer have to worry about the bottom because we found a common denominator. So we really now just get to solve the top. So now we're going to solve this equation right here for x. How easy is that going to be?
Where did the bottom go? You subtract 42 to both sides.
Yeah, we would...
Or you could add the 40 to it. Or you
So we're going to subtract the 24 over to isolate the x.